Well, here we are in week 8 and getting towards the close of your course. We have this week and next week to go. So many of you are working on your second and final assessment items with your units of work, and I've seen quite a few of you are almost finished that, which is great to see. So this week we're going to discuss just how you can improve your units and get, of course, the highest possible grades possible for exceptional units of work that you'll be able to use when you go out into schools. Here I've provided you with a range of images of different design challenges that students have been involved in various schools. So I've got a young girl here in her plastic bag dress that she's created, some students doing some gardening, and various other activities, building their own cubby houses or shelters, some go-karts. This one was where some students built some devices for carrying surfboards, and various other activities that you can see. Now, some of these won't relate to any of the prompts that are in your assessment outline, but I thought I'd just go through and give you a few more ideas for when you get out into schools and are starting to think about your own design challenges. And then we'll start talking about what you need to do for your unit outlines for this course to make sure that they're as effective as they can be, and of course get high marks for them being so. Now, land yachts is a very popular activity. This was done actually as a linked activity with some students in Norway, where students here built land yachts to race along the beach, while those in Norway obviously built them to race along the snow. And it's a fun activity for students to explore different aspects of construction. Air surfing is a fun little activity you can do with students, particularly if you're doing a flight unit where students are building planes or some sort of aircraft, and it's just a nice simple activity for them to create tumble-wing aircraft. Now, bridge building is one of the ones that you're involved in, and this goes through a couple of videos that talk about, well, the first one talks about bridge building, the second one's more of an encouragement video about how students want to see the use of technology incorporated into their design challenges. Shelters is a very popular activity, and we're going to talk about that one in particular this week. And having students design their own shelters and then construct them, and those designs can be done on the computer in terms of CAD programs. This is being done in SketchUp, and there's various competitions that students can get involved in whereby they can submit their designs and get involved in seeing how other students around the world or in their own country are doing similar design challenges, and even win competitions or win prizes, and sometimes get a chance to go interstate or even internationally to compete. But cubby house or shelter design has been very popular at all year levels, and you can see some examples there using shelter design even in the very earliest years. Remembering though, it still needs to be based around a problem to be solved. Now, school bags is a very popular design challenge for young students. Of course, they're very involved in carrying around their books, and this particular design was created so that it also provided a desk and chair for the student. Cardboard boats is a very popular activity here on the Gold Coast because of our access to waterways and so forth. I used to do this one here with this course, but because now I'm getting you to do many of these things independently, it was just a little bit too dicey for me to encourage you to do these where I couldn't actually supervise you and provide some safety oversight. But with appropriate oversight and monitoring of the students, particularly if you've got a pool at your school or nearby, it can be a very fun activity where students have to create boats out of cardboard and see how long they float and how quickly they can get across a piece of water, etc. Cardboard furniture is another very popular one, generally because we've got access to cardboard and it's very cheap. and it can be used in some very interesting design processes and some quite complex ones. On that, one very popular cardboard activity is Kane's Arcade, where a young boy creates an entire amusement arcade out of cardboard, and has become somewhat of a sensation on the internet through his demonstration of his various arcade elements. But that can again be a great activity for a class group to get involved in, each student or groups of students creating different arcade activities and then having a fair and letting other students in the school come along and partake of those various games and activities. Now, traditional foods is a very popular one as well, for students to investigate and discover what sort of traditional foods can be eaten and coming up with a design challenge around that. And there's just a few prompts there, and particularly some ones set here on the Gold Coast where we have our own particular flora and fauna related to Aboriginal foods, and there's some various links or some contacts there that you can get involved in if you want to incorporate those aspects. So one of the easiest ways of improving your units and bringing them to a higher level is to investigate various design challenges and other activities that are run on the internet or as competitions or activities that are supported by organizations such as NASA or Google or Apple and other groups like that. Now, the advantage here is that they've put a lot of effort into developing lots of resources and also setting it as a challenge beyond what you would have just any student or group of students be able to complete easily. They generally set the bar a bit higher and also then force teachers to actually consider just what the students might be capable of beyond what they might think of as an appropriate challenge. So a couple of ones from NASA where students are getting involved in the designing of rockets or spacecraft or interplanetary settlements on other planets, and a whole range of other activities there. So while you may not have expertise in certain areas, there is more than likely some organization somewhere that does have expertise and is willing to support students in those sort of challenges. So I really encourage you, whatever design idea you've thought of, go and find out how the best teachers in the world are actually using those challenge ideas and incorporating them into their own teaching, and more often than not into collaborative projects where students from around the world might be able to get involved in. So if you want the high grades, I would certainly expect you to have investigated and explored just what's possible with the design challenge idea prompts that I've provided you. Now, I've just given you some very, very basic ideas, generally drawn from the curriculum documents, but teachers have gone far, far beyond these basics and incorporated really, really engaging, exciting design challenges and units of work built around them. One touchstone I've always used is, are your students going to remember your unit of work 10 years' time? Are they still going to be talking about the fantastic project that they did back in year 4 when they designed a rocket or they created a bridge and tested it out and went through all those processes of exploring what was involved in creating a bridge? Okay. Think beyond just what you have to do for the curriculum. Think about what will make it a memorable, exciting, engaging experience for your students many years hence. Of course, yes, we do lots of activities in schools, we do lots of learning processes, but we can also make them engaging and fun. And particularly in subjects such as design and technology and digital technologies, where you've got more latitude and ability to incorporate themes more easily into your teaching, then there's really no excuse to come up with a boring unit where they're just doing a whole lot of activities just because the teacher has told them they've got to do these activities. Make them engaging. Read back over the unit of work that I gave you on challenge-based learning, and just think about what's possible to incorporate into your unit outlines. This is where you really need to start being creative. Okay, it's not just a worksheet. It's not just a standard lesson template that you've seen 1,000 of before. Start thinking about how you can really make your unit exciting and engaging. Now that's why I don't want to constrain you to a unit planning template, because it's very hard to get out of a template what you really want to achieve with your students and with an exciting, engaging unit. So use an essay format, explain how and why your unit is going to be an incredibly engaging activity for your students. That's your challenge for your unit planning. Now, other projects, Young ICT Explorers is a great one for digital technologies. It's run every year, and there's a little video there showing it, whereby a few hundred students from around, well, used to be around southeast Queensland. Now they've got ones happening in New South Wales and Victoria. I think there's also one running in Townsville this year. So it's becoming very popular, but it's a bit like science fairs, where students undertake their own particular projects. Young ICT Explorers, students undertake digital projects. They might involve creating a robot or a computer program or some new software or a computer game or a video. There's a whole range of different approaches that students can take to engaging in that. And that can be a good context for which students can showcase their work and enthuse them to doing more than just what's required for their assessment. Although hopefully in certainly lower primary they haven't quite gotten into that mode of thought yet, but it does happen. As I expect many of you are in that mode at the moment. So, as you come to do your design challenges, here's some more resources explaining how a particular challenge could be done in years 5 and 6 related to shelter design. Now again, this isn't in essay format, this is much more tabulated format, and this doesn't go through the full process that you have to do, and it also doesn't relate exactly to the the curriculum that you're going to be using. But it's reasonably close to give you some ideas and prompts and get you moving on the right direction. So in this particular unit, there is a design challenge where students are going to create an emergency shelter. Now that still hasn't been put into a context and a problem. Okay, you need to put your units into a problem-based context. So why are they creating a shelter? Now in this case, I put in the suggestion that it was for use in natural disasters. But make your context much more exciting and engaging for students in primary school. What particular natural disaster? Is it for the Thunderbirds, so they can race in and set up these shelters out of Thunderbird 2, or whichever one it is? Okay, think about how you can frame it so that the students can consider what is then an appropriate shelter. What is a shelter that fails to meet the objectives of the task? Okay. Does the shelter have to be able to resist a certain amount of rain, a certain amount of wind, a certain amount of earth movement? Is it for use in tsunamis or in droughts? Okay, think through the different sorts of shelters that are going to be required and some conditions that you're going to have to place on them so that students can test their solutions against those conditions. So there's various elements there that you can consider around shelter design, and again, remembering this is from the old curriculum, but there's a whole range of learning outcomes that are possible to be achieved with shelter design. And I've given you a few videos there whereby students have been involved in various competitions or contexts where they're creating shelters, be they mobile shelters or shelters for use in emergencies or shelters for homeless people, and a whole range of links there that can give you other ideas. So here there's a range of different learning outcomes that could be achieved by a shelter design. As usual, looking at the different materials involved, okay, is a common and easy one to use, but this one wouldn't have much to do at all with food and fibre production. Although you could look a bit about fibre production in terms of the materials that might be used. So there could be some possibility of linking that in. But as always, it does have a strong processes and production skills. Okay, all of your design challenges, by the very nature of them being design challenges, should incorporate all aspects of the processes and production skills. It'd be very unusual for a good design challenge not to incorporate those. And then don't forget to look at the achievement standards. Of course, this will relate specifically to your assessment. How are you going to assess students' learning? How are you going to show evidence that they have met these achievement standards? Okay, so you need to make sure you've read those and incorporated these achievement standards into your unit outline description, and make it very clear that you're using some specific strategies to actually verify student learning. Now that's an important aspect. Okay, it's not just that you've done some sort of assessment, okay, that you've done some classroom observation, or you've done a quiz, or you've done them having written a document or done a presentation. How are those things going to actually give you evidence of them having achieved these elements that they need to show that they've achieved by the end of year 5 or their particular year band? So that's another aspect whereby you can distinguish yourself from just a basic unit outline, whereby you might mention a few assessment techniques. But if you want the high marks, you really have to say, how are these approaches you're going to use to assessment going to actually verify whether or not a student has learnt something or not? And a good way of checking that is just saying, okay, what would it show for a student that has failed that particular aspect? How are you going to be able to tell a student between a B and an A? Okay, what would a student do to demonstrate that they've done it at an exceptional level or at a failing level? Okay, these are things you need to think through as you do your unit planning, particularly around the assessment aspect. So there's a range of different things there that you can incorporate into your design challenges. So other aspects that you want to actually demonstrate in order to achieve highly. Probably the key thing that's going to distinguish students from those that just pass to those that achieve credits and above will be whether or not you've actually incorporated a problem-based design challenge. Okay, well, you're all going to incorporate a design challenge. Okay, it's almost impossible not to. But are you going to do it as though it's simply a task for them to achieve, such as these prompts describe? Is it just they're going to design and test a semaphore system? Or have you provided a context around that in which creating a semaphore system is simply one possible solution to a particular problem? The problem might be communicating a message between Mount Olympia and Athens that the Greek army has been destroyed or has been victorious. Now, there may be a whole range of different ways of doing that. One is to send a runner to run the marathon, to reach the city and tell them that it's what has happened. But there may be other methods. It might involve shining mirrors or sending up smoke signals or creating a semaphore. Okay, there could be a whole range of different ways of communicating a message in that way. And then they could look at digital ways that they currently use. Okay, if we had access to current technologies, yes, they might just use their mobile phone, or they might use a satellite phone if they don't have mobile phone coverage, or they might use the internet. So there could be a whole range of different modern approaches to that. But given the particular constraints, say particular mountains and no internet coverage and no electricity, etc., the semaphore may come out to be the best solution for that particular problem, and then going ahead and actually creating that and testing it and making sure it actually works. So for that sort of approach, you would expect students to then be investigating a whole range of different alternatives to the semaphore system before they come up with that as their solution. So these prompts give you a particular solution that you do need to come up with and create. But that's only halfway through the design process. You need to show the consideration of the problem itself, the generation of lots of different possible solutions to that problem, and then the problem that you've, or the solution that you've decided to implement, and then how you've actually created that solution and evaluated it. So if you just create the solution as I've described in these prompts, you will have only achieved half of the design process. So that's probably the key aspect that will determine those just passing and those getting higher grades. Now, of course, many of you want to achieve the highest possible grades. Now, for that, you do need to go into a bit more detail. Now, one is that it's got to be a very engaging, exciting, interesting project and design challenge. Okay, so you need to put your imagination, research how other teachers have done so with other ideas similar to the one you've chosen. Okay, and actually create and describe a really interesting, engaging unit of work. You need to make sure that your assessment doesn't just list out a few assessment strategies, but actually shows how it's going to actually verify that students are at a particular level of achievement. And good assessment needs to be able to do that at multiple levels of achievement. Yes, it might be great between distinguishing a student getting an A and not getting an A, but does it also tell whether or not a student is getting a D or an E, or a D and a C? Okay. Really good assessment will be able to differentiate between the 5 basic levels that you'll find in primary schools. And that can be rather difficult, particularly with your lack of experience, but I understand you're doing assessment modules at the moment. So hopefully you'll have some ability to draw upon and incorporate effective assessment into your unit outlines. Now, the other aspects that you need to be able to demonstrate. Let's just scroll down to them. So, how well you've actually planned out your unit will also be an important factor. If you just put in everything possible, and if you say it's a 10-hour unit of work and you're clearly doing 50 or 60 hours worth of student work, that's going to be a problem. Likewise, if you have given a whole lot of time where it's not necessarily going to be required. Now, really good unit outlines actually incorporate some flexibility to adjust things depending upon student progress. If you find that students have done their investigation phase very quickly, then you might either have some additional work for them to do, or you might give them more time on some of the other phases. Likewise, you're going to have students that work at different rates. How well you've differentiated your unit outline so that you can incorporate students that are struggling and students that are gifted and achieving beyond what the standard group of students would be achieving, would be another differentiator between a standard unit outline and an exceptional one. So you might want to think about some strategies that you can incorporate that can show some differentiation between what students do. Now again, I know that's going to be a challenge for you because you don't have a lot of experience with differentiation at this point in your careers, but really good teachers doing really good units will differentiate to a large extent and allow multiple projects to be occurring, sometimes very different projects, where you've got students at one level of ability doing very simple design challenges, while students at the other extreme are doing incredibly complex design challenges, maybe working with people outside their school. Now, this is another area that you can think about in terms of differentiating your unit outline or your unit and design challenge is, are the students just going to be able to draw upon their own expertise, or are they going to be able to draw upon their parents, possibly even experts outside of the school, such as people from scientists or engineers. You may be lucky enough to have some parents who are engineers or involved in various trades and professions that you can incorporate into your whole class group, but allowing students to actually try to contact and get advice from experts beyond your classroom can be a very effective strategy for students in their generating phase or in their investigation phase. So how you use ICT and various technologies to permit students to engage with that is another aspect. How you allow them to use ICTs for their design processes. Are they going to design their products just with some sketch paper, or are they going to use tools such as SketchUp or various simulation software? If you've got a particular design challenge, have a look at what simulation software there might be out there that the students can experiment with. There's simulation software for amusement parks, for bridge building, for various shelter designs. There's a whole range of different tools that you could incorporate with your students or allow them to investigate and incorporate that can improve their generating phase and come up with different ideas based upon their simulation of what's possible. So that's another area that you could explore and think about. Okay, then of course you need to be able to show that your unit is going to address some of the elements of the Australian curriculum. Now it won't address all of them, and it won't even address all of them within the particular subject, such as designer technology or digital technologies. But certainly it should address some. It'd be very, very hard for you not to, given that I've given you the prompts that are based from the Australian curriculum. But don't try to force elements. If it clearly doesn't have a strong relevance to your unit, then leave it out. It's fine to only address one or two from the knowledge area. Certainly I would expect everyone to address all of the ones from the processes and production steps, but don't just try to include them all because you think that would be better. Now, how then to differentiate? Well, there's also a whole range of other curriculum elements that you could explore incorporating into your unit outline. There are, well, of course, there's the cross-curricular aspects, whereby you can mention how other learning areas could be addressed through your unit outline. But don't spend too much time on that. You could very easily get bogged down into all the learning outcomes associated with health and PE or mathematics or science or other areas. Mention them very briefly, but don't get deeply involved in explaining how your unit can be done cross-curricular. What you could spend a little bit of time though explaining is how you address some of the general capabilities. Now, one of the general capabilities is ICT use. So if you're using some simulation software or some design software or various things like that, that is using some ICTs in your actual unit outline. But there's a range of other general capabilities that you should be looking at. So I'll leave it to you to consider those. And there's also a couple of other areas that are mentioned in the curriculum. There are the various curriculum priorities, such as Aboriginal and Torres Strait Islanders or Asian studies, that you might also consider incorporating into your unit outline. So, with these various approaches that I've given you, for each of these you need to come up with a problem that these represent a solution to. And you need to create then the design challenge being students going through attempting to solve that problem, coming up with a whole range of possible solutions to that problem, of which these represent just one. Now, say for example the design and create a concept map. Part of that problem-solving process could be to consider all the different ways that a concept map could be created. The various digital tools that are available, the various manual tools such as pencil and paper or so forth, or putting it on the interactive whiteboard and things of that nature, but investigating all the various digital technology tools that are available for creating concepts and mind maps. There are ones that allow you to share them online. There are various ones that allow you to do more and more detail or include pictures, etc. And students, or yourselves in this case, exploring all of those, comparing them, examining which are more effective than others in achieving the actual solution to the problem, would be the digital technology aspect of the task. So just creating a concept map is not a particularly involved challenge. Yes, it involves learning something new and things like that, but it's not really a design challenge. But actually using a concept map to solve a problem. Okay, so identifying what the problem is that a concept map would be the best solution for, and then looking at the various concept maps, tools and ways of creating a concept maps that are available, and then selecting which of those is the best, does start building it into a good, effective digital technologies activity. So again, you can see that in the various other aspects. If you're doing a picture graph or an infographic, there needs to be a reason why creating an infographic is the solution to a particular problem. So it's a little bit easy for you in some respects in that you're allowed to create whatever problem you want that meets the solution that you have to show. But in other ways, it's a bit more challenging because you need to then go back and consider the problem as though you didn't know that the infographic was going to be the solution. Okay, and you have to generate as many different ideas and possible solutions to your problem, and then select infographics as being the best solution to that problem. And then again, you would explore the various software and tools that are available for creating infographics, and which of those are going to be the best approach to meeting your particular design challenge. So it's not just creating a graph with some pictures of students and so forth. That's the very, very basics of the task, and something I would certainly expect you to be able to do, but has very little to do with the actual design challenge itself. It's simply the context for the design process to occur within. And yes, learning how to use an infographic piece of software is one aspect, but really it's an ICT aspect of digital technologies. Much more important is actually comparing various software tools, working out whether or not what they want is possible with the various software, trying to actually explore why some software does allow you to do certain things and others don't. Does some software allow you to share things on the internet and work collaboratively on the internet? Other software may not, but it may have other advantages and so forth. These are the things where students are going to learn about digital technologies. Just using a piece of software to create an infographic is an ICT. It's not really part of digital technologies. We do it, of course we use ICT in digital technologies, but it's not part of the actual curriculum of digital technologies. That is where we're actually learning about how computers and information can be presented, and various tools can allow us to present that information in different ways. That's where the power of digital technologies comes in. Okay, so that's probably enough to give you some ideas so that when we meet and have our discussion, we can explore the various approaches you're using. Now, as for students showing me what they're doing, you can show your tutors and myself, although pick one please, don't do both, what you're up to, but only once. And I will only give very, very general advice. Generally, I'll tell you if you're failing, and if you are, then I'll give you more specific advice as to how you can hopefully not fail. But if you're after more specific advice than that, particularly if you're after advice that will help differentiate you between a distinction or a high distinction or a credit and a distinction, etc., I won't be providing you with that level of advice. Okay, you need to be able to do that yourself at this stage. But if you've got specific questions, then I'm much more likely to answer those. If you just show me your work and say, is this good or not? I'll say yes. Or I'll say no and tell you where it's failing and how to get across the line in that respect. But if you only ask very general questions, then you'll only get very general answers. But you can ask specific questions, and you can ask those of your tutors, and you can ask them of myself. So please do so. And I look forward to having a discussion and hearing about the great projects you're working on. I know quite a few of you are well on the way to getting them done already, which is great to see. But for those that are still starting on this process, and possibly you haven't looked at a lot of the videos, you may need to go back and actually look at what we've been discussing over the last few weeks and get your head around what's involved. If you're still trying to find the actual criteria sheets and so forth, it's in week 1 in the booklet or the course description booklet that I provided you in week 1. That's where all the material is about these different activities and criteria and so forth. So I hope to see you all, or as many of you as possible, at our discussions on Wednesday. Bye for now.